So in this problem, we're asked to calculate some power values. So we're asked to calculate the dissipated power in each resistance. So that's in these two resistors. And then we're asked to calculate supplied power, and that'll be from these sources. We have a 6-volt source and a 2-amp source. And so we should have 4 power calculations that we have to do. So let's begin with that and see how this works. So let's start with the resistors. So the first one we want to look at is this 4-ohm resistor. And we recall that power is equal to the voltage times the current, right? Well, we also know from Ohm's law, which is V equals IR, that the voltage, since the voltage is equal to IR, we can solve for anything we want. But in this case, we just need the voltage. So we'll replace that in this equation here. So now we'll replace the V with IR. So now P is equal to IR. This is where we replace the voltage, times I, or what we more commonly write this is I squared R. So this is the equation we want to use. So because we know our current and we know our resistance, so our current through this device has to be the 2 amps, because that 2-amp source is pushing everything through the resistor. So now the power for the 4-ohm resistor will then be I squared, which is 2 squared, that's our current, times 4. And so when we calculate that out, we should get 16 watts. 16 watts. So that's the first device. All right, so now let's move on to the next resistor here. So again, we'll go back to our power equation. P is equal to VI. So in this case, we know the voltage because they share the same input and output. So if there's 6 volts across here, there has to be 6 volts across here, as they're in parallel. So we know the voltage, but then we also know the resistance. So we don't know the current. So this is a case where we'll take Ohm's law and we will solve it for the I term. So in this case, it'll be I is equal to V over R. So here we'll make that replacement. So when we do that, it'll be P is equal to V times V over R. Or the way we more commonly write that is V squared over R. So in this case then, the power for our 2-ohm resistor will then be V squared over R for that resistor. We know the voltage is 6 volts squared, and then the resistance is 2 ohms. So when we calculate that out, we get 18 watts. 18 watts. So here's the 2 power dissipation calculations for each resistor. The 4 ohm is 16 watts. The 2 ohm is 18 watts. Okay. So now we need to go back and see if we can determine for the sources. So let's take a look at these. So the first one we'll look at is the 2-amp source. And let me highlight that what we're working on. So the 2-amp source right here. So again, we do the same things before, remembering that P is equal to VI. So we know the I, that's 2 amps, but we need to know the voltage drop. So just as we did before, we know that we have this node, and so from that node to this node, it's always going to be a 6 volt total drop. So that means from here all the way to here is 6 volts. So we should be able to calculate what the voltage drop is across this resistor, because we know from Ohm's law V equals IR. So if we know the voltage drop across that and the total voltage drop, we should be able to deduce this. So let's see if we can find that out. So the voltage drop across the 4 is going to be, remember it's just IR. So we know the current, that's 2 amps, our current source. We know the resistance is given to us, that's 4. So that's going to be 8 volts drop across the resistor. So now we use that, and we just say that the voltage drop across the entire node has got to be 6 volts. So if we say the voltage drop across our 2 amp source plus the voltage drop across the 4 has got to equal to 6 volts. So plugging those values in that we know, that means the voltage drop across here has got to equal, let's take it one step at a time, plus 8. It's got to equal to 6. So we subtract 8 from each side. So the voltage drop across the 2 amp source has got to be negative 2 volts. Negative 2 volts. So now we come back here to our power equation. We say then the power is equal to the voltage times the current. So for P, for the 2 amp source, that's going to be negative 2 times 2. That gives us a negative 4 watts. And it's negative because it's supplying the power in this case. Okay, so that leaves one left, and that would be our 6 volt source, so this guy here. So let's see what we need for that. Again, going back to P equals VI, and here we know that we know the voltage because it's a voltage source, so we need to try to figure out the current. Well, we know that there's 2 amps going this way, and so that if we can calculate what the amperage is going through the 2 ohm resistor, then we should be able to deduce what the total amperage is coming out of our source. So that being the case, we know we can use invoke Ohm's law again. So in this case, we're looking for I. So I, we solved up in the corner there, is equal to V over R, right? So we know the voltage drop across our resistor. We've already said that's 6 volts because it's in parallel. And then the resistance is 2 ohms. That's given in the problem. So that would be 3 amps. So there's 3 amps going through our resistor. So now we should be able to do a node calculation of this node, of all the currents entering and leaving the node, to determine what the current is coming from our source. So if we add them all up, they should equal to 0, right? So if we say I through our 6 volt source, and we're going to say entering the node is positive, and then we say plus I from our 2 ohm source plus I from our 2 amp source, that should equal to 0. Again, entering is positive, so again we'll have I6, that's one we're looking for. The 2 ohm resistor we said is 3 amps leaving, so that's going to be minus 3 because we said entering is positive. And then the current source is 2 amps leaving, so that's going to be negative because we said that entering was positive. And so that has to equal to 0. And so that would imply then, solving for I6, that current is 5 amps. All right. So now we can do our voltage calculation. So back to here. So again, P is equal to VI. Now, we have to think about, since we're going in a voltage loop in this direction, that our voltage here will be negative because we hit the negative terminal first in the direction of our current. So that being the case, it'll be a negative 6 times 5 amps. So negative 6 volts times 5 amps. And that gives us negative 30 watts. And again, it's negative because it's being supplied. So there's our 4 power calculations. We should be able to do a quick check here and say that the power supplied should be equal to power dissipated. So in other words, power supplied should be equal to power dissipated. So the power dissipated is equal to 16. It's the power from the resistors plus 18. And that gives us 34. The power supplied, again, we're not worried about the signs here, is 30 plus 4, because it's just magnitude. Again, that's 34. So you can see that that checks out.